Hello everyone. The topic that we will be discussing is on Gauss's law. This law was first stated by K.F. Gauss. This law gives the relation between the electric field intensity at a point on a closed surface and the net charge enclosed by that surface. This surface is called a Gaussian surface. So one should be remembered while selecting the Gaussian surface, the surface must avoid the point charge on the Gaussian surface itself, because there on the surface the electric field intensity is infinitely large. So in international systems of unit, Gauss's law states that the surface integral of electric field intensity over any closed hypothetical surface called Gaussian surface in free space is equal to 1 by epsilon naught times the total charge enclosed within the surface. So mathematically we can write that the surface integral of E dot ds is equal to 1 by epsilon naught times q. So this summation from I equal 1 up to n over qi is the total charge enclosed within the surface. So remember that this S is a Gaussian surface. If we look at this equation, this one is nothing but it is phi. So this is Gauss law. So now let us solve one numerical problem by using Gauss's law. So the question is like this. Question: a point charge Q, say equal 10 microcoulomb, is located at the center of a cube of side 0.04 meter. And the question is, find the electric flow through each phase of a cube. So that's the question. So according to this question, we have a cube like this, and there is a charge Q equal 10 microcoulomb at the center. So we have learned earlier that if we have a charge which is stationary or which is at rest, so there is an electric line of force, a number of electric line of force coming out from the charge if it is for plus. So according to the question, this Q is equal 10 microcoulomb. If you see from here, this one is closed surface. So we can apply Gauss law. So this can be written as 10 into 10 to the power minus 6 coulomb in the SI unit. And if you use Gauss's law, so what is the total electric flux? What is the flux through all face of a cube? It is phi. So this is equal to surface integral of E dot ds, and this one is equal to how much? 1 by epsilon naught times q. So here the total charge enclosed within the surface is 10 microcoulomb. So from here, what's the flux? Flux is equal to 1 by epsilon naught times q. So what is epsilon naught? Epsilon naught is a known quantity. Epsilon naught is a known quantity, and its value is 8.85 into 10 to the power minus 12, and then the unit is Newton inverse, then Coulomb square, and then meter, like that. So that is the SI unit of epsilon naught. So if we put this value of epsilon naught in this equation and the charge q by this quantity, so what is the total flux? What is the flux to all faces of a cube? Is 1 by 8.85 into 10 to the power minus 12, then multiply. Q is 10 into 10 to the power minus 6. So if you put the unit here, the unit is Newton inverse, then Coulomb square, then meter minus 2, like that. And then the charge is Coulomb. So if we take this 10 to the power minus 12 to the numerator, so 10 to the power minus 12 become 10 to the power plus 12. If we take the numerator, so plus 12 and minus 6 become 10 to the power 6. So if we take this n, we'll get n. If we take n to the numerator, so c to the power minus 2. If we take this c square to the numerator, it becomes c to the power minus 2. So minus 2 and plus 1 become c to the power minus 1. And if we take this one, this m to the power minus 2, then it becomes m squared. So that is the unit. So 10 divided by 8.85 is approximately 1.13. So that is the total flux, or that is the flux through all the faces of the cube. But we can see from here that 6 faces of equal area makes a cube. So therefore, what is the flux through only one face? Here the question is being asked that find the electric flux through each face of a cube. So flux through each face of a cube is equal how much? It is 5 total divided by 6. So if you put this value in this equation, so this 10 to the power 6 remain as this, so n c to the power minus 1 m squared, then 1.13 divided by 6, so approximately it turned out to be 0.188. So you can check this numerical value. So in the next lecture, we will discuss on the application of Gauss's law.